Welcome everyone to our Ask the Experts session. And today's topic is Edge AI, where MLOps ends and Edge Orchestration begins. This will be a session where we'll cover this topic and also give you guys the opportunity to ask questions if you have any. So if any questions arise throughout this session, feel free to post them in the chat and we'll cover them as we go. And we'll also have a little more time for questions towards the end of the session. And our expert today is our Senior Solution Architect, Fredrik Jansson, and I'll have him to my left, and also you have him on the screen. And with that, I'm going to hand over to you, Fredrik.
Thank you. So today's topic is AI, and specifically AI at the edge. There will be a couple of parts to this one. The first one will talk a bit about why we think it's a great idea to actually store AI or machine learning models in containers and using containers as a medium to distribute those to the edge and also host them at the edge in a model serving engine. So I'll talk a bit about that first. Then we're going to go into a demo, actually using the Avassa platform to distribute and upgrade models at the edge. And at the end, I'm going to have a little teaser about what will hopefully be another event of this, where we hope to show in more detail a use case we're working with Databricks on, using their MLflow engine to train models and deploy them using Avassa. So let's go here. So everything I'm going to show today is actually publicly available. So if you go to GitLab Avassa Public, you'll find an Edge AI project there. And that GitLab project actually contains everything that I'll show you today. You can modify it to your heart's content, but the images for all the containers we're going to run are also here. So please take a look at this URL in case you're interested. So why do we think it's a good idea to have store models basically in containers? We think that the container abstraction allows you to take a container or a model in this case, or any application and its dependencies and compose that together. And in this case, we're using TorchServe as the serving engine. This could be anything. This could, for example, be the MLflow serving engine from Databricks or any other engine. Then the plan is that you add your model or models, as we use in this demo, to that container. In almost all cases, you will also have some kind of a front end sitting between your application that is utilizing the models and the model serving engine itself. And this could be for various reasons. Maybe you need to transform the data a bit or the requests before sending it to the serving engine, or maybe do something with the response before handing it back to the client. So let's scroll down here a bit. So the idea is using, in our case, GitLab, a CI/CD pipeline. You have your serving engine of choice, and then as you train your models, you're gonna start out with model version 1, and you're gonna package that together with the serving engine. And then once you use that in production for a while, or you deploy it somewhere, you're probably gonna update that model version to a version 2 and 3 and 4 and so forth. And now you're gonna build new container versions for every iteration of that. And while it may seem wasteful in a sense to put a model together with the serving engine, we hear some questions around, well, if I don't change my serving engine and I only update my new model, will that not be wasteful building an entirely new container? But the cool thing about containers is that they are really layered. So if you don't touch your torch serve, that layer is constant, so to say, and the Avassa platform will actually only download it once. So even though you release a new model version 2 using the same torch serve, the only thing in reality that will be downloaded and distributed to all your edge site is actually the new model version. So it becomes a really convenient way of packaging the model and the serving engine together. You can test them together. You know exactly what version of torch serve is tested with the exact version of the model. And the end result is still that you're only going to distribute the actual model when you distribute this to all your edge sites. So yeah, this is what it looks like. I'll briefly touch upon the model serving endpoint. We are using a Python library called Fast API that seems to be popular. Again, this is not important. It takes an HTTP request, it forwards it to the model serving engine, takes that response and hands it back to the client. The cool thing about Fast API is you can really achieve a lot of things with just a few lines of code. So we decided to use that. That said, I'm actually gonna head into the demo. So hopefully at least a few of you have seen the Avassa control tower, which is the UI up here. And what I've done is I created an application called Image Classifier. And it really consists of the torch serve, which we get from here. And this torch serve now has the model baked into it. And the other container that we use is the Fast API frontend. Again, just a Python application that we run in front. I've also told the system that the API frontend is actually listening on this port. So by telling the system that you need an ingress, that means that something on the network, in this case, it will be my laptop, should be able to reach this application from the outside. And in this case, we're going to do that on port 8080. And I've deployed this to two sites, to two clusters. So I'm going to click here and we can see that I have an API container that is up and running. It comes up on a specific IP address. And I also have the torch serve. But again, this torch serve is not reachable from outside, so to say. It will only be the API container that we can talk to. So it's deployed, it's version 1.0, and it's up and running. Then for the demo, I actually deployed a Jupyter notebook to one of the clusters. So again, this is a really simple application. It's a Jupyter Docker container. It has declared an IP address that it listens to. And I actually logged into that one up here. So 168.453, you can see that this is the address here. I have some pre-made notebooks in here that we can use. So just gonna import the stuff in here first. And what I can do is I can actually ask the API image, the Python code, what models do you serve at the moment? So if I run this one, takes a couple of seconds, I actually get an answer back and it tells me, and it actually forwards this request into the torch serve container, what models are available. So I get a response back saying it's serving a ResNet model at the moment. And this MAR file is really a TorchServe specific format. It's a model archive file. And then to get it to do some kind of a classification, I'm pointing to an image. It's an image of a crocodile. And then I can ask the system to classify this model. So I'll send this. Again, I'm sending it to the API image, and it forwards it into the TorchServe, and I get a JSON object back saying that it's 82% sure that this is an African crocodile. Then I mentioned in the beginning, we actually have two models packed into this. But if I try to do this, I actually get an error saying it can't find that DenseNet model. And the reason for that is simply because of the demo in version 1 of the TorchServe that I'm having. I'm actually just packing in the ResNet model. So what we'll do is I'm going to go back here into the control tower, and we're going to do an upgrade. So here I can do edit, and we can call this version 2.0, and then I'm going to point to a new version of my TorchServe image. So again, this on the surface, it may look like we're going to download TorchServe and the new models, but the only thing that will happen in reality is that the new ResNet model will actually be downloaded. So I'm going to see if I can find my button here somewhere. It's hidden here. So I'm going to update this. And now if we go back, we can see that I've downloaded the new image. It sits in the control tower. I'm going to go to my deployment, take image classifier, do an edit here, version 2.0. And now we will roll it out to one of the clusters. So this will take a couple of seconds. Now it's actually up and running. So now I'm going to head back into my Jupyter notebook here. So again, if I run this request, I now get a different response. So now I get the DenseNet model that we use, but the serving engine also tells me that I now have a ResNet model, a different model. So in the real world, you may not serve multiple different models in the same container. But a more realistic use case could be that you would actually have like DenseNet 161 version 1.0, and then you run that for a while, you retrain it, and then you're going to have a DenseNet 161 version 2.0. But just to show something here. So now if I go back here, we can rerun this one, and I expect to get the same answer since it's the same model. And it is. But now I can also send the same image to the DenseNet model. And here I get back a slightly different response. This guy is 92% sure it's an African crocodile. Very good. So that's really all I planned around demos. So if you have any questions, please post those in Zoom. But I'll talk a bit more about, I'm going to switch my sharing here. About number 3 here and what I hope we can show in the future. So what you saw now was an example of you have some tooling, some MLOps tooling where you manage your machine learning models, you train them, maybe you test them, and then Avassa kind of takes over when you have that model ready, and we distribute them to the edge and you can use them there. What is missing in this is really getting data back from the edge into your MLOps tool. So you could, for example, think about the fast API container that I have. If that container would actually capture the requests that come in to the model and also capture the responses we get back from the model, we could actually utilize those in future training. And that is what the example use case is all about with Databricks, is that we capture requests coming into the serving engine, and we capture the responses coming back, and we take that data and we feed it back into Databricks, and Databricks can now build what they call an inference table with these requests and responses. And you can then measure things such as a drift in your model. You can also potentially use some of that data to retrain your model to make it even more accurate. And then you can kind of close the loop. So now you have a new version of the model based on the data that you actually capture in the real world. And again, you feed that into Avassa, and now you can deploy that to your 1,500 edge locations or whatever you have. So this is something I'm really excited about, and we hope to get Databricks on a call like this in the future to talk a bit more about this in detail. With that said, I hope there are at least a few questions.
Thank you, Fredrik. That was great. I could just start off also by asking a question. If you were to have a whole set of applications running at the distributed edge, and you have completely different life cycles of the trained models and the other applications, how can we address that? How does this fit into the whole picture?
I mean, it depends on the model. I would say that in certain cases, when you develop the model, maybe the calls you make to the model serving engine will change. In that case, you have to make sure that they go in tandem, so to say. If the model is just a retrained model of the same sort, it takes the same parameters and the responses are similar, you can probably treat them as totally different beasts. Otherwise, you have to make sure, of course, that when you develop or deploy the new model, that the application goes in tandem. So I think it depends a bit on the changes you make to the model.
Thank you. So I do have a question here in the chat. If you run multiple models for different use cases in the same device, do you then propose to use multiple independent containers? If the model serving server uses different versions in the two use cases, then it would consume a lot more space than if you use the same version in both.
Yes, I guess there are pros and cons to this as well. I'm guessing a bit, but I assume that you could end up with a tight integration between your model and your serving engine. And if that is the case, you may want to keep them as separate containers, so to say, because then you know that model A works well with this version of TorchServe, for example, and model B works, and you have tested that with another version of TorchServe, so to say. Then I think it would make sense to keep them separate. Maybe the benefit of putting them in the same container, just as I did, I'm thinking it might be slightly easier to control resource consumption, tying the model serving engine to GPUs and so forth by actually deploying them in the same container. So I think there may be use cases for both, but to your point, is that will consume more disk space, maybe. And the reason I say maybe is if they are actually using the same model serving engine under the hood, our registry is smart enough to figure out that they should share that layer, and all Docker and Podman is also smart enough. So I'm actually not sure that you would waste that disk space end of the day.
Great, thank you. And then we have, maybe it's more a comment than a question. Let me know if I'm wrong about that. But we do have a comment that is, we produce ML and DL models, convert them into microservices, and then containerize them. Kubernetes create container instances to deploy them.
Okay, yeah, that is, even though we are not Kubernetes based, the thinking is the same. So I take that as validation on what we propose here, really.
Also have a question, which GPUs do we support, and we as in Avassa?
Today we support NVIDIA GPUs, including slicing of those. We are also working on and have the first release of supporting Intel GPUs out there. We actually have a potential customer testing that out at the moment. That is Intel GPUs.
Thank you. If not, we can actually, we can jump to the next slide. I want to mention before we leave that you're more than welcome to also join our next session. It's going to be on May 30th, and it's going to be more focused around the monitoring and observability of the distributed edge applications. With that, we're going to stick around for a few minutes, but either way, we want to thank you all for coming. And if you have any questions, post them in the chat, or else we hope to see you next time. I do have an additional question in the chat. How do you handle resource allocation on the devices? For example, one device with one GPU, what happens if two different use cases depend on that single GPU, I suppose?
That is a great question. It turns out many GPUs actually support multiple applications sharing the same GPU. So that kind of works right off the bat. The bigger challenge is if you have a GPU and you want multiple applications to share that, can you resource constrain the application so they don't tread upon each other, so to say, or starve each other? And that is a bit more complex, and we haven't really solved that yet. We think that NVIDIA has some support for setting up, in lack of a better word, resource profiles on GPUs. So that is actually something that we are investigating to see if it would make sense to have that in our platform and be able to set up those resource constraints between applications. But in general, it works really well for multiple applications to share one or more GPUs.
Thank you. Hopefully that answered the question, and do let us know otherwise if you want us to elaborate on that. All right. With that, thank you all again for coming, and we hope to see you next time.